Hello students, in this video we're going to discuss about lens makeup formula and lens formula of ray optics class 12. And before you watch this video, please watch the video that link is in the description box. Watch the video that is made on the refraction at spherical surface. Okay, then you will understand, otherwise not. Okay, so I have made a video on that topic already, so link is in the description box. Please go through it and then come to this video to watch this video. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. Okay, and before I explain this, let me give you the handwritten notes, then I will explain it. Okay, first take the screenshot of these notes. Okay, this is first and this is second and this is third page. And if you need the PDF of these notes, then you can send a message, okay, on WhatsApp. So now let's start. Let me show you again. This is the first page, this is second, and this is third. Okay, so now let me explain this. Now here you see, this is the lens and its refractive index is N2, and on both sides of this lens we have air, so of refractive index N1. Okay, so here what happens, actually this is the object and its image will be formed by this side of the lens at I1, at this point I1. Okay, then this image will act like an object for the second surface and its image will be formed at I2, and this is the final image. Okay, so hope you have understood this. So first we are going to consider the first surface. Okay, so hope you remember this diagram. You have I think I have already explained about refraction at spherical surface. If you haven't watched that lecture, please do hit the link given in the description box, where I have explained refraction at spherical surface. So here you see, so I have considered this surface is this one first. Let me consider that way. So now you see, this is the object O, and so this is the medium with refractive index N2, and this is with refractive index N1. Now you see, this light is going, this is the denser medium. Okay, this light is traveling and it strikes at this point, and this is the supposed center of curvature, and this is I1, this is C1, and this I1 is here, this one. Okay, so hope you have understood this. Now you see, let me make it I1. Okay, let me make it clear. So this is C1, this is C, the optical center, and this is C2. Okay, so as this is object, so I have taken this is U, object distance, and image distance of this I1 is V1, and image distance of this final image I2 is V. Okay, this is V, and radius of curvature of this surface is this one, that is R1. Okay, R1, and radius of curvature of the second surface is R2 here on this side, you can see, right? Hope you have understood this. This is R2. R2. Okay, so now just wait, let me clean this, give me a second. Okay, so here you see, then this intersect this principal axis at I1, where the image is formed due to this intersection, and here this is the u, right, object distance u, and the image distance here is v1. Okay, this is the image distance, and this is the radius of curvature r1. So in this case, so when this for this diagram, so if you have what's that refraction at spherical surface, so if we consider refraction at this surface, then we should get n1 by minus u plus n2 by v1 is equal to n2 minus n1, right? Here the image distance is v1, right? So now you see, now let us consider the refraction at this surface. Okay, so at this surface, you see, so if you consider this surface, the diagram will be like this. So now let me clean this. Okay, so now you see, first let me clean this. Okay, if you consider the second surface, the diagram should be like this. Okay, now here is the I1, here is I2, and this is the center of curvature C1. Actually, its center of curvature should be here, C2. Okay, so now here you see, here I2 is the partial image for this surface. So here it is v1. V1 will be the image distance for this surface. Okay, this is the medium of refractive index n2, and here n1, and I1 is the actual image here. This is v, and this v1, this image distance for the first that we have considered here for the first surface, this I1 was the image actually, which is image distance is v1. So this image distance will be considered as now object distance, because this image will be regarded as object for this second surface. This is the second surface, and here is the first surface, right? So now you see, though we have considered this is the image, virtual image, this is actually virtual image, but the incident ray, the rays are actually coming from this side. Okay, so this is the object on the left hand side, and it is traveling from this side, right? So that's why we have to consider this distance as negative, though we used to consider this side as positive and that side as negative. But here the object, the virtual object, is on this side, positive side, but the rays of light are traveling from this side, from n2 side, okay, from negative side. So that's why we have to consider this v1, we have to consider this v1 as negative, minus v1. Okay, and this is the image distance for us. So instead of minus u, we're gonna write minus v. Okay, minus v1, right? Now it is traveling from the medium of refractive index of n2 to n1. Okay, in the first case, this was obtained when the light was traveling from the medium of refractive index of n1 to n2. So now reverse case. So that's why here instead of n1 we're gonna write n2, and instead of minus u we're gonna write minus v1, because now I1 is considered as the virtual object of the for this surface, right? Second surface, and the image distance n2 will be replaced by n1, and so the image distance for this time, the final image is I2 and the image distance is v. So here we're going to write v is equal to, so then again change the refractive indexes n1, n2. Okay, so n1 minus n2 divided by r2. Now the radius of curvature is r2. Okay, for this time. So hope you have understood this. This is equation number 1 and this is equation number 2. Now we're gonna add these two equations. Okay, so let me clean these things. Okay, so what we're gonna do now, we're gonna add these two equations, right? That's very simple. Just adding equation number 1 and equation number 2. If you add these two equations, then what you're gonna have on the left hand side, from the first equation we're gonna get this left hand side, then plus from the right hand from equation number 2 we're gonna get this, right? So now you see, just give me a second. Okay, let me cut it. On the right hand side, what we're gonna have, we have to add these two, right? So let me copy it from equation 1, and from equation number 2 we're gonna get this. Okay, so now you see here, this is negative and this is positive. Okay, so these two will be cancelled, right? Because you see, this minus, this is plus, so it becomes negative, right? So these two terms will be cancelled. And if we now simplify, then what we're gonna have, so now you can write this as n1 minus n1 by minus u, then plus n1 by v, then is equal to, now if you take here you see, if you take minus sign common from these two, right? If you take minus sign common here, then this will be n2 minus n1, right? This negative term will be positive and positive term will be negative, right? So hope you have understood this. Then we can take n2 minus n1 common, right? On taking negative sign common from this term, from this term, if you take negative sign common, this plus will be minus. Okay, then we can write, we can take n2 minus n1 common. Okay, then within bracket we're gonna get 1 by r1. From these two terms we have taken this common, n2 minus n1, right? Minus, as we have taken minus sign common, so minus 1 by r2. That's what we have got. So now let me copy this last step and let me take a new slide so that I can explain the remaining part. So here you see, this was the last step we have got. So now what we can do here, we can divide both sides by n1. Okay, by n1, then what we're gonna have, then 1 by, first let me write the positive term first, 1 by v, then minus 1 by u on dividing both sides by n1, then n2 by n1, then minus n1 by n1, that will be equal to 1, right? That will be equal to 1, and here we have got 1 by r1 plus, not plus, minus 1 by r2. That's what we have got. Now you see, suppose if we have two media, medium 1 and medium 2, this is of refractive index 1 and refractive index 2, then refractive index of medium 2 with respect to medium 1 can be obtained by refractive index of medium 2 divided by refractive index of medium 1. Okay, so that's why we can replace this term by this 1 by v minus 1 by u is equal to n2 1 minus 1 by r1 minus 1 by r2, and this is the Lensmaker formula. Okay, this is the Lensmaker's formula. Now if you see, and you see, in case of a convex lens, let me take this lens. If you keep the object at infinity, or if the object distance is infinity, u is infinity, okay, then this ray pass through the focus, right? That means image distance will be equal to f, focal length, right? Image distance will be equal to focal length. So if the object, okay, if the object is at infinity, that means u is infinity, and the image will be formed at focus f, right, at focus. So in that case image distance will be v is equal to f, right? Then if we put so let me take, this is equation number 3, okay. So if we put u is equal to infinity and v is equal to f in equation number 3, okay, let me copy this equation number 3 and let me go to a new slide, okay. This is the equation number 3. If we putting u is equal to infinity and v is equal to f in equation number 3, then we're gonna get 1 by v, v is 1 by f, 1 by u, u is infinity, 1 by infinity, that's gonna be 0. So simply we're gonna get this equation, right? Since 1 by infinity is 0, so we can write directly this 1 by f is equal to n21 minus 1 by r1 minus 1 by r2. That's what we will get, right? So this is equation number 4. Now if you compare these two equations, equation number 3 and equation number 4, you can see that the right hand side of these two equations are same. So that's why it is obvious that left hand side of the two equations must be equal, right? So comparing 3 and 4, okay, comparing equation number 3 and equation number 4, what we're gonna have, 1 by f is equal to 1 by v minus 1 by u, right? 1 by v minus 1 by u. So this is the lens maker, sorry, this is the lens formula, right? This is the lens formula, and this equation number 3, this was lens maker's formula, right? So hope you have understood this. Thank you for watching. See you in the next video. Bye bye.